Hi everybody and welcome to Module 7, the final module of a Pluralsight course on modern software architecture. As usual, Dino Esposito is speaking. Domain-driven design, DDD, has been the first serious attempt to systematize design and development of software systems. In this class, I went through the inspiring principles and common practices of DDD and discussed a few supporting architectures for the actual implementation of systems. What does it mean? Design driven by the domain, a larger version of the acronym DDD. What's the exact meaning we should intend? Abstractly speaking, it indicates the idea of building a piece of software that mirrors the business domain. In the beginning, domain-driven design came with the idea of having an object model like the business domain. In this class, we also discussed how focusing on tasks makes it easier to model the system. Finally, in a time in which users are much less passive and forgiving as they were only a decade ago, the role of the user interface and its impact on the user is critical. So, in this final module, I'll offer a sort of a wrap-up about domain-driven design and also discuss ways it applies to legacy code, task-based design, and user experience. There are many known ways to define legacy code. Often by legacy code we mean code that exists, that some other people wrote, and that is complex and undocumented enough that everybody is scared to touch. Legacy code is primarily code that just works. It might not be doing things in the most appropriate way for the current needs of the business, so you feel like it has to be properly refactored and possibly rewritten. In other words, you don't like to have it around. But because it works and because everybody is constantly late on something, there is never time to do it, and in the end, you can hardly get rid of it. However, sometimes what we call legacy code is not necessarily badly and poorly written code. Sometimes it's just code that now, for the current state of the business, should be doing additional things or differently. But for a number of reasons, it's risky to touch it, or it just takes time because of the complexity it carries. Let's go through some of the common aspects of legacy code. Any existing and running code has probably its own data model established and implicit. It may not be obvious how data is moved around and if data is packaged in classes or source items. Determining what goes in and out of a legacy code and creating a sort of an interface may then be hard. On the other hand, legacy code was written to have some work done, not to be reused and showcased around. In addition, it could have been written years ago, following good practices of the time that now just turn to be obsolete. How to incorporate legacy code in new applications? All in all, my favorite approach is trying to expose the legacy code as a service if all possible. If not, I would seriously consider rewriting. But this is just a general guideline I use. But in the end, it always depends case by case. So I'd say you start with the idea of rewriting the system and get all the abstractions you need. If some features you need to rewrite then exist in the legacy system, I'd consider incorporating existing assets as services rather than rewriting everything from scratch. Needless to say, this only works if the new system you need has exactly the same features and the same behavior. If you can disconnect the legacy code and recompile it as an independent piece of code, then put it in a bounded context, expose it as a service and create a facade around it to make it work with the rest of the new system. It may not work, but if it works, it's just great. Not because you can do something, you should be doing that particular thing. Not all legacy assets are equal. Some can be reused as services, some not. Some are just old and obsolete. Before integrating legacy code, make sure you carefully evaluate the costs of not rewriting from scratch and also the costs of integrating legacy code as a service. Next, if legacy code can be turned into a service, then just let it be and focus on other things to do. Crude, is a long-time popular acronym to indicate a system that focuses on 4 fundamental operations in relationship to both the user interface and storage: create, read or retrieve, update, and delete. In this regard, it's essentially correct to state that all systems are Crude systems. Well, to some extent at least. The Crude cycle describes the core functions of a persistent database, typically a relational database. The code implements the create, read, update, and delete operations and saves the resulting state to the database. While it's probably correct to state that nearly all systems are Crude to some extent, the devil is in the details of what actually turns out to be the object of those operations. Is it a single individual entity, or is it a more complex and articulated data representation? Let's try to list a few common attributes of a Crude system. First and foremost, a Crude system is database-centric. The model of data available to the code is exactly the same being persisted. Deletions and updates affect directly the data stored. This means that at any time, you know the current state, but you are not tracking what has really happened. A Crude system, for the most part, has a relatively basic business logic and is being used by one or very few users and deals with very elemental collections of data, mostly one-to-one with database tables. In summary, a Crude is typically quick and easy to write, and subsequently, it often looks unrealistic these days. When we hear or pronounce the words "it's basically a Crude," we are right in that we want the 4 basic operations being implemented. But tracking actions or not, the amount of business logic and rules, concurrency and dependencies between data entities change significantly the scope of the system and raise significantly the level of complexity and effort. So it's basically a Crude system, but must be devised in quite a different way to be realistic and effective as of today. Sure, a Crude system is database-centric. In modern software, however, the persistence model is just one model to think about. Sometimes, to better process relationships between collections of data, you need to build a different model that expresses behavior while saving state, or just actions through a different model. More often than not, the context of change must be tracked. An update cannot simply be overriding the current state of a given record. It might be necessary that it's tracked, whether it is an update to the state, tracking the delta, and all of them in the life of a data entity. Plenty of business logic, concurrency issues, and interconnected entities, graphs of objects populate the modern software, and systems must take that into account. So, we still have Crude operations against a database, but create deals with graphs of entities, read fills out views, update and delete log the change to the current state of the system. And today, C, U, and D, create, update, and delete, are commands, and reads, the R, are queries. And this is why the CQRS approach is vital and fundamental for today's applications, as we discussed in Module 5 of this course. The easiest way to capture an idea has always been a sketch on paper and sometimes paper napkins. In fact, many great ideas and projects in history have been first sketched out on the napkins of some cafeterias. What you see is what you get is an old slogan of the graphical user interfaces of development tools like Visual Basic, but what you see is what you get is also today a philosophy we can apply to software architecture. What users first perceive of each and every application is what they see and what they get as they interact with the application. What they see is commonly referred to as the user interface. What they get, including sentiments and emotions, is user experience. User experience is a very frequently used expression these days, but what is UX exactly? It can be wrapped up by saying that the user experience is the experience that users go through when they interact with a given application. In light of the user experience, what is the most effective way to architect a system? Start from a database where relevant will be persisted, arrange some business logic out of requirements and persistence constraints, and then put some UI on top of everything. This is how it mostly works today, and if something gets lost along the way you serve a UI and a UX that customers just don't like, well, that is a problem to face. I'm sorry, and you start just from scratch or sort of that. What if instead you just start from what users like and approve, and then from there you build the system? The system internally may not be perfect when you first deploy it, but you can be sure that the core input and output is just right. To build a software system today, is the classic bottom-up approach still the most effective? Personally, I'm leaning towards a different top-down approach. The bottom-up approach to software architecture is based on the idea that you understand the requirements and start building the foundation of the system from the persistence model. Your foundation is a layer of data with some endpoints that, like pins, are looking for an outlet. As long as users are passively accepting any UI enforcements, this has been the case for several years, let's just say that, you can then accommodate any foundation, perhaps at the cost of introducing in the middle a less than optimal user experience. But now, more and more users are actively dictating user interface and user experience preferences. Therefore, you'd better start designing from some front end they certainly like. Endpoints to connect to the rest of the system are exposed from the presentation layer, like pins, and the rest of the system is then designed just to match those endpoints, like an outlet can be designed just to match given pins. And persistence is designed to save data you need to save in the shape that data comes your way down the stacks. In the end, it is a presentation and everything else is a sort of a big black box. The whole point of top-down design is making sure that you are going to produce a set of screens and an overall user experience that fully matches user expectations. Performance and even business logic can be fixed and fine-tuned, but if you miss the user experience, customers may have to alter the way they do business and go through their tasks. It may not be ideal. So, in the user experience design approach, the first step is building up UI forms and screens as users love them. You can use wireframes and wireframing tools for this purpose. At this point, once screens have been approved, you have a complete list of triggers that can start any business process. Hence, you implement workflows and bind workflows to presentation endpoints. For example, in an ASP.NET MVC application, this means invoking a workflow process from a controller class. A workflow represents a business process, and you create all the layers that need be there, repositories, domain services, whatever else that serves the purpose of implementing successfully the business process. For the whole method to work, however, it's key that you hold on and iterate on the UI forms approval process until you get users signing off, approving explicitly. And when they say, yes, this is what we want, and this is the way we like to work with this application, only then you proceed. Any time you appear to waste at this stage is saved later by not likely having to restructure the code because of a poor or wrong user experience. In summary, sign off on what users want and use sketches and wireframes to get their approval. A sketch is a freehand drawing mostly made to capture an idea. A wireframe is a more sophisticated sketch with layout, navigation, and content information. You may not need mockups instead, as mockups are just wireframes with some CSS and graphics attached. It may be required instead that you produce a prototype just to show live how the whole thing would work. A prototype is a simulation of the real system, and its implementation usually have very little to do with the implementation of the final application. So it only appears to work as the final app, but there is nothing under the covers behind the surface that can likely be reused. The point is, avoid doing any seriously billable work until you are certain about the front end of what you're going to create. More in detail, for each screen, UX-driven design suggests you have a basic flow chart, like determine what comes in and out of each screen and create appropriate view model classes. Make application layer endpoints receive and return such view model data transfer object classes. And finally, make the application layer orchestrate any subsequent tasks through the layers down the stack, so repositories, domain services, external services, and whatever else you may need to set up and work with. In UX-driven design, a second architect role works side by side with the classic solution or software architect role. This is the UX architect. Responsibilities of the UX architect are defining the information architecture and content layout, defining the ideal interaction, which means essentially storyboards for each screen and each UI trigger, being around the definition of the visual design, and more importantly, running usability reviews, even filming users if necessary. This is done in order to identify bottlenecks in the storyboards as soon as possible. For the role of the UX architect, a few tools are helpful. Here is a short list. There is a Balsamic, which is a wireframing tool, UXPin, which is a platform, a cloud-based platform with the ability to create wireframes and storyboards and testing and collaboratively gather feedback about the work being done. Infragistics Indigo is another analogous product that also is available as a standalone, and Just in Mind is yet another tool with wireframing and storyboarding capabilities offered on-premise and through a cloud subscription model. UX architect, in the end, is only a role, and the same individual can be at the same time acting as the UX and or the solution software architect. Hey, if you're here, it probably means you went through the entire course and hopefully enjoyed it. A few final words about the state of the art of today's software architecture then are in order. First and foremost, the definition of domain-driven design, DDD, should be revisited to add emphasis on the tools for domain analysis, such as ubiquitous language, bounded context, and context maps. Second, in the building of each bounded context, the layered architecture is key to have and best of breed today. Layers over tiers are preferable as scalability these days can easily be obtained with stateless, single-tier, small, compact, simple servers implemented perhaps as web roles in some cloud platform and then scaled according to the dashboard and the rules and the possibilities of the cloud platform. The design of systems should be top-down, as it starts from what users really want and expect. This means great user experience by design and built from the grounds up. And finally, to achieve everything, to build the actual backend of the system, CQRS, command and query, responsibility segregation, and event sourcing are the new and really important hot things these days. Separating command and query stacks makes everything in the building of the application more natural, convenient, and simple to code, and even simple to optimize because the stacks are separated and the command part and the query part can be deployed and optimized without affecting each other. Event-based persistence, yet another cool aspect of modern software architecture, lets you not miss a thing and makes the entire solution subsequently easy to extend in the future by adding more features and supporting more notifications, more commands, and subsequently more events. What else? Thank you very much. That's all. Thank you very much for taking the class. And you know about that old actor's joke? That's all, folks. Thank you very much for coming. If you liked the show, please let everybody know. Otherwise, keep it for yourself. Thank you very much. Till next one.